Hello, my name is David. I'm a principal engineer with Dell, and today I'm going to talk about configuring the Windows Time Service on the PDC emulator using group policy. As you're most likely aware, the domain controller that holds the PDC emulator role is the authoritative time source for a domain, and therefore it must be configured to obtain its time from an external source, which is just any time source outside the domain. In the forest root domain, this means a source that's outside the forest, typically a public NTP server. In a multi-domain forest, only the PDC emulator at the forest root level must be configured to get time from outside the forest. The other PDC emulators of the child domains can be configured to sync with the domain hierarchy. In doing so, they'll obtain time from a domain controller in their parent domain. One common way to configure the time service on the PDC emulator is to use the registry. This works well, but unfortunately if the role is moved to a new server, the configuration does not follow the role. There's a solution for this, and that's to configure the time service using group policy. That's what I intend to demonstrate here. This domain contains two domain controllers named DC1 and DC2. As you can see here, DC1 holds all 5 FSMA roles. First, I'll check the registry to see what settings have been configured, and I'll do so by launching regedit, which opens to the correct registry location. That's HKey local machine, system, current control set, services, W32 time, and parameters. And there are two main values we're concerned with here. This type value, which is currently set to NTP, and when type is set to NTP, the NTP server value, a few lines up, comes into play. And that's currently set to time.windows.com and pool.ntp.org. Both of those entries have the hex 8 flag associated with them. I won't get into the definitions of those flags, but hex 8 is often a good one to use on a domain controller. And you'll notice those entries are separated by a space. So if we close regedit, we can confirm that the settings in the registry are in fact being applied by running w32tm/query/configuration. And this just shows the current configuration of the Windows Time Service. Here we can see that type is set to NTP and NTP server is set to the two values that we saw in the registry. And importantly, we can see local next to those values, indicating that those values are set on the local machine, i.e. in the registry. So now let's look at how to configure this by group policy. We'll launch Group Policy Management. And the first thing we need to do is create a WMI filter. This will cause our configuration to only apply to the PDC emulator. So to do that, we right-click on WMI filters in the left pane and select New. And we can give the filter a name. I'll call it PDC emulator. And a description. It's optional. Now we click Add. And make sure namespace is set to root \CIMV2, and then type this text to create the filter itself. And it's important to type this exactly as shown. Select star from Win32_computer system where domain role equals 5. And then click OK. Confirm that the text looks correct and click Save. So now we have our PDC emulator WMI filter, and we need to create a GPO to apply that filter to. To do this, we'll right-click Group Policy Objects, select New, and give it a name. I'll call it Configure Time on PDC emulator. Click OK. You can see the new GPO up there. It has no settings applied, so we'll right-click that and select Edit. And our location is going to be under Policies, Administrative Templates, System. Scroll down to the bottom. And Windows Time Service. Expand that and select Time Providers. Right-click Configure Windows NTP Client and select Edit. And first thing we need to do here is set it to enabled, otherwise we can't configure any settings. Once it's enabled, you can see a number of settings can be configured. We're only concerned with type and NTP server. We set type to NTP as shown earlier, and then set NTP server to the same values that we had in the registry. I'll just change that flag to hex 8 and add pool.ntp.org, give it the same hex 8 flag, and once again those entries need to be separated by a space. We'll click OK, and then we need to right-click on Enable Windows NTP Client, select Edit, and set that to Enabled as well. There are no settings under this one, we just need to enable it. Click OK there, and close the Group Policy Editor. Now we have our GPO and our WMI filter. We need to tie the WMI filter to the new GPO. We do that by clicking the GPO in the left pane, and then looking way down at the bottom, you'll see a WMI filtering section. And in that drop-down list, we just select the WMI filter that we created and click Yes to confirm. So now that filter is associated with that GPO. So the GPO will only be applied to the PDC emulator. Since the PDC emulator, like other domain controllers, is located in the domain controller's OU, that's where we need to link this GPO. Right-click on the OU and select Link an existing GPO, and then select the GPO that we just created, and click OK. The GPO is now being applied to the domain controller's OU. So now on our PDC emulator, we need to run gpupdate/force to refresh group policy. When that is completed, we can confirm that the GPO is being applied by running gpresult/r. Scrolling up to the computer settings section, and under Applied Group Policy Objects, we see Configure Time on PDC Emulator. That confirms that the GPO is being applied, and now we'll confirm that its settings are being applied by once again running w32tm/query/configuration. We can see that type is set to NTP, and the NTP server values are set as expected, but both of them indicate policy now instead of local. And that just indicates that those settings are set by group policy instead of being set on the local machine's registry. So now we'll switch to our other domain controller and refresh group policy on it as well. And when that completes, we'll run gpresult/r, see if the GPO is being applied here. If we scroll up to the computer settings section, we see the following GPOs were not applied because they were filtered out. And the configure time on the PDC emulator GPO is listed there, and it is being denied by a WMI filter, and it's the filter that we created. So now we'll check the Windows Time Service settings here with the w32tm command. And we can see that this domain controller is set to sync with the domain hierarchy. That's what NT5DS means. And that is set on the registry because the group policy object is not being applied. So everything appears to be working as intended. Let's see what happens if we move that PDC emulator role to the other domain controller. There's a PowerShell command for doing that. It's move-AD directory server operation master role, which I will tab complete. Use the identity parameter to specify the destination, and then the operation master role parameter to specify the PDC emulator role. Type Y to confirm, and we got no errors. Let's update group policy on the new domain controller. And I forgot to confirm that the role actually moved, so let's check that. You can see the PDC role there is owned by DC2 now. We've already updated group policy, so let's run gpresult and check once again. This time we do see, in fact, that the configure time on PDC emulator GPO is being applied. It's no longer being filtered out because this is the PDC emulator. So let's check the time service settings again. And as expected, we see that type and NTP servers are both set by policy now. So let's switch back to DC1 now that the role has been removed. NetDOM Query FSMO confirms that the PDC role is owned by DC2. So we're going to update group policy here again. That completes, and we'll check the Windows time settings here one more time. And we see that both settings have the local indicator now, again indicating that they're set on the local registry and not by group policy. As intended, the time service configuration followed the PDC emulator role when it was moved from one domain controller to another. Once again, my name is David. I'm a principal engineer at Dell, and thank you for watching.